Good day, class. For today, our topic is chemical bonding, but to be more specific, we're going to deal with concepts, nomenclature, and bonding of covalent compounds. Here are the learning objectives. First, write and name chemical formula of covalent compounds. Second, which is the last, show the bonding of covalent compounds using the Lewis Electron Dot Structure or the LEDS. Now, let's start the discussion. From what you've learned from our previous discussion, covalent bonding is a chemical bond formed by the sharing of one or more electron pairs between two atoms. And these atoms must be nonmetals. So when you allow or when there is bonding happening between two nonmetal elements, the type of bonding is what we call covalent bonding. Now, the product formed from this bonding is what we call covalent compounds. Again, covalent compounds are compounds containing predominantly covalent bonds. Or to make it more easy and for you to remember what covalent compound is, always remember that this is the product of the bonding happening between two non-metal elements. And the other term that you can actually use for covalent compounds is molecule. Now let's move on to the nomenclature procedures involved in covalent compounds. Now let's start with naming chemical formula of covalent compounds. So here are the steps that you have to be mindful of. One is name the first element followed by the other element. Second is include prefixes that indicate the number of atoms in the molecule. So you can identify certain number of atoms involved in the compound by merely looking to the subscripts. Okay? So we'll teach you about that later on. Third, which is the last, change the suffix of the other non-metal element into ID. Okay, now let's try to use these steps by having these examples. Now, before that, let me give you this particular table for the prefixes. So if you see a certain number, a subscript, which is 1, 2, 3, so on and so forth, the prefix that you have to add to the given element name are here, okay, as pointed by my cursor. So 1 mono, 2 di, so on and so forth. Again, prefixes are words which are here as an examples that must be added before the word, okay, before the element. Okay, so while the suffixes or the suffix IDE, you have to change a certain letters at the end of the given element name. So therefore, prefix is added before an element name or a given name, while suffix is added at the last part of a certain element. Okay, hopefully you recall that in your English subject. Now, as mentioned, we're going to use those steps for these examples. So we have H sub 2s. If we're going to name this, following the steps. So first step says that we have to name the elements in this compound. So we have here hydrogen and sulfur. So you've seen here that hydrogen has 2 atoms because 2 here is a subscript. Okay, so following the second rule, which is we have to identify the prefix involved here. So 2 means di. Okay? We're going to go back to the said table, which is this one. Okay, so hydrogen has 2 atoms or 2 atoms in the given formula. So the prefix that we have to include there once we name the given formula is di. Okay. Now, sulfur, you've noticed that there's no number here as a subscript. So, alam naman natin, if there's no number, that means this is 1. Okay? So, normally, hindi naman natin sinusulat si 1. From what you've learned from my previous discussion when I discussed ionic compounds. In that sense, are we going to include the prefix? Yes. So, the prefix for 1 is mono. Okay? So, hopefully you follow that one. So, all in all, so it should be dihydrogen. So, 1 means mono. So, for the next name of the given formula here, you have to write it in small letter. Mono, then combine it, sul, and as part of the step or the rule, you have to change the suffix into ID. Sulfate. Okay? So, dihydrogen monosulfate. Earlier, following the steps, so naming the elements involved, you have hydrogen, you have sulfur, right? Now, hydrogen has 2 atoms based on the subscript here. So that means the prefix is di. So sulfur has 1. Therefore, the prefix here is mono. And we have to change the suffix, which is this one, into IDE. That's the reason why this formula is dihydrogen monosulfide. Hopefully, you follow that one, okay? Based on how I recall again the steps. So, hopefully, you got it right. Okay? Now, let's have another example, which is SO sub 2. So, follow pa rin natin yung steps. We have how many atoms or atom involved in the formula. So, let's start with the S, that is sulfur. So, only 1 because you've noticed that there's no number here. Alam na natin that means 1. For oxygen, so that is the name of the next element. Oxygen has 2. So, a sulfur, that means mono because of the 1. Okay. Oxygen, there's 2, that means di. Now, another rule that you have to bear in your mind is that if the first element in the compound for covalent compounds has 1 subscript, we no longer add this prefix mono. Okay, sa madaling salita, if you've noticed that the first element in the given compound has 1 atom, the mono, the prefix mono, will no longer be added. Okay, that's the rule that you have to remember also. So therefore, oxygen, the suffix must be changed into IDE. So that becomes sulfur dioxide. Okay? So, uulitin lang ni sir, no need for you to add mono if the first element has 1 subscript. The word mono, no need to add that when you name the covalent compound. So, hindi siya monosulfur dioxide. It should be sulfur dioxide. The mono, the prefix mono, you will add that if that is on the second element. Okay? For your covalent compound. Or the other non-metal element. So, hope you follow that. Now, let's have the third example, which is CCl sub 4. So, using the steps again. C here is carbon. How many atom or atoms? Only one. The prefix is mono. Cl means chlorine. How many atoms? 4. So 4 is tetra. We're going to revisit again the table, which is this one. So 4 is tetra. And please, class, screenshot this slide, this particular slide, so that you can have a copy for the prefixes. Okay? Now going back again for the example letter C. So we have 4. And in that case, we're going to change the suffix of the chlorine to ID. So mono, because that is found in the first element, the prefix mono will no longer be added. Okay, so therefore this is carbon. Tetra, that is for the prefix chloride. Okay, because of the suffix that we change for the non-metal element chloride. Okay, so hopefully we're doing great. Now, fourth example, we have PCl sub 5. P means phosphorus. You can still check the name of the element symbols sa inyong periodic table of elements. So, P, phosphorus, how many atom? Only one, mono. Cl is still chlorine. How many atoms? 5, that is penta. Okay, change the suffix into ID. So that means, putting all together, we have phosphorus pentachloride. Okay? So, mukhang dumadali na sa atin. Now, last, which is NO sub 2. So, we have nitrogen, 1 atom for this particular formula for the element nitrogen, that means mono. And for the oxygen, we have 2 atoms, and that is di. Change the suffix into IDE. Putting all together, you have nitrogen dioxide. Okay? So hopefully you follow well my discussion or explanation on how you will name the given covalent compounds, okay, based on its formula. Kaya class, if you're going to name H2O, this is a covalent compound because hydrogen is non-metal, oxygen is also non-metal. The name of this one is not just water. Okay, water is the common name. So following the rule the rules that I gave earlier, this is dihydrogen monoxide. Okay, so this is monoxide. Bakit? So you have 2 atoms per hydrogen, making it di. Okay, so you have 1 atom per oxygen, making it mono. You just change the suffix of oxygen into I. So therefore, the covalent name of this compound, which is a water, is dihydrogen monoxide. Okay. Now let's do the other way around, which is writing the chemical formula of covalent compounds. Now, here is the rule that we have to follow. The name of a binary molecular or covalent compound indicates the number of atoms of each element present in the compound. So, to make it simple, we have to be mindful of the prefixes, the prefixes that you can actually observe in a given compound in order for you to properly write based on the chemical. Okay? Now let's apply this by having these examples. So for the first example, we have dinitrogen tetroxide. So be mindful about the prefixes. So we have here di for the nitrogen. So you have to determine as well element symbol for the element name or elements involved in the compound. So nitrogen has capital N as its element symbol. So di means 2. That refers to the subscript, which is 2, or the atom. The number of atom of nitrogen in this compound. So oxygen is for the oxide. So capital O. And tetra is 4. Okay? If you're going to recall the table, again for prefixes. So therefore, this is the formula. So madali lang, right? Now, another example. So we have bromine. So there's no prefix. That means it has only one atom involved in the formula. So bromine has element symbol Br, and chloride, trichloride. So chlorine, this is referring to chlorine, Cl, and tri means 3 for the prefix. Okay? So hopefully nakuha natin. Third example, nitrogen triodide. So ibig sabihin lang yan, wala ulit prefix here. So nitrogen is N. Only one atom for this compound. So iodide, so that means iodine. So how many atoms based on the prefix? 3. Okay? So hopefully nasusundan ng mas malinaw. For example, we have tricarbon dioxide. So there is prefix na tri-trion. So carbon has element symbol C, capital C. Be mindful of writing the letters sa capital. So C sub 3, dioxide, O sub 2. Okay? So moving on, for the last example, we have diphosphorus pentoxide. So phosphorus, we have capital P, but there is prefix di, that means 2, sub 2. P sub 2, pentoxide, oxygen oxide, O penta or pent, 5 yon. Okay? So P sub 2, O sub 2. Now, let's talk about how can we illustrate or draw the Lewis Electron Dot Structure of compounds under covalent bonding, okay, or following covalent bonding. Now, before that, let me share you concepts regarding the different types of covalent bonding, which is first is based on number of bonds. So we have single bond, double bond, and triple bond. So for single bond, formed when only one pair of electron is shared in the bonding. Okay, example is H sub 2 or the hydrogen gas. Now for the double bond, formed when two pairs of electrons are shared. So example is O sub 2 or the oxygen gas. And we have the last one, which is triple bond, formed when 3 electrons are shared among the elements involved in the compound. So example is N sub 2 or your nitrogen gas. Now class, there are chances that in a given compound, combinations of bonding can be seen. Okay, pwedeng merong may single, may double bond. Okay, so you would see that moving forward. So single, double, and triple bond are the types of covalent bonding based on number of bonds. So mas mai-elaborate natin to once we have examples. Now, another thing that you have to be mindful of is the type of covalent bonding based on electronegativity. Electronegativity is not new to everyone. I mentioned that when we have our previous discussions. So you can tag the covalent compound as polar covalent bond if it shows values when you get the difference of electronegativity value of the elements involved in the compound. Polar covalent bond kapag ang value is less than 1.9 or equal to 0.5. Okay? And non-polar covalent bond if the electronegativity difference, the value is less than 0.5, non-polar. I will not further elaborate this one kasi nga na-aral na natin. But this is still important in covalent bond. Okay? Now, we're going to use again this periodic table of elements with electronegativity values para we can identify if the compound is polar or non-polar in terms of its bond. So let's have an example. So we have H2O or your water, or if we follow again the rule for naming it, we have dihydrogen monoxide. Okay, so first thing first that you have to do in order for you to illustrate the LEDs of this compound is that you have to get the total amount of valence electron or the TAVE. Okay, so this is again total amount of valence electron. So you know it already. How can we get the number of valence electrons or electron for a certain element? By electron configuration or by merely looking to the position of the element in the periodic table, specifically the group, as long as the element is a representative element. Okay, not part of the transition element. Kasi you have to do electron configuration for that para you can perfectly determine the valence electron. But for representative elements, hindi na. Yun ang pinaka-technique na. Now, hydrogen element belongs to the first group, which is this one. So normally, the valence electron of that is 1. Now, oxygen is another element. So, representative elements, alam na natin na this part up to this. These are just transition elements. Okay? So, hindi siya nagpa-follow ng rule na binibigay ko for the technique for determining the valence electron. So, hydrogen has 1 valence electron, oxygen has, so 1, 2, 3, 4, 5, 6. Okay, kasi nga ito 1A, 2A, 3A, so on and so forth. So hanggang 8A yan. Pero pag ayupak yan, 1, 2, 13 na ito. 14, so on and so forth up to 18. So there are 18 groups na for your periodic table, and there are 7 periods horizontal. Okay? So ito part pa rin to ng 6 and 7 periods. So sana nasusundan si Sir siya. So therefore, your oxygen is found on 6, so may 6 na valence electron in inyong oxygen. So balikan lang natin. So 1 valence electron, oxygen has 6 valence electron. Now, in order for you to get the total amount of valence electron, you have to make this formula as this chemical formula into an equation. Paano yun, sir? So the subscript, okay, so 2H, the H will serve as variable, so that refers to the amount of valence electron for this particular thing. So saan po nanggaling ang 2? From the subscript, kasi there are 2 atoms for hydrogen in this particular formula or compound. Plus total amount, so that means we're doing addition here. So how many atoms na meron tayo for oxygen in this compound? Only 1 kasi wala namang number or subscript here. So indicate mo 1 plus 1, O. O is the variable for the oxygen that has 6 valence electrons. So 2 times 1. Sa galing ng 1, valence electron of your hydrogen. Plus 1. Sa galing ng 1, subscript of oxygen. 6. Kasi you just substitute the 6 for oxygen. Yan yung valence electron of oxygen. Okay? So, hopefully nasusundan. So, multiply lang. 2 times 1 is 2 plus 1 times 6 is 6 at you have 8. So, this is your total amount of valence electron na nasusundan. So, para saan to, sir? Now, this is important for you to double check your answer. Okay? Again, we're doing LEDS, therefore we have to follow octet rule. Still, for all the elements involved in the compound. Yan ang tatandaan natin. Now, there are 2 atoms for hydrogen and there is only 1 atom for oxygen. So, in this case, we have to identify who among the elements is the central atom. Okay? Sino ilalagay natin in the middle? Okay? So, central atom means the atom, okay, that you will locate or position in the middle. Okay? Kaya ang central atom. So, the central atom has the lowest number of subscript, okay, or the atom that can form most of the bonds. And as another definition that we can put for or can a way for you to describe central atom. Okay, so among the two, hydrogen and oxygen, which one has the least or lowest number of atoms? Diba? Observe naman natin, your oxygen is 1 compared to hydrogen. But there is another rule that you have to remember as well, class, that if atoms involved in the formula has the same number of bonds or atoms involved in the formula, you have to identify which one has the least electronegativity value. Okay, and that must be the center in your structure. Okay, but for the case of hydrogen, okay, hydrogen and halogens, ano po ba tong halogens? These are elements found in your group number 7. Okay, sila chlorine, so on and so forth, yan yung mga halogens natin. So, hydrogen and halogens are always or must be or must always goes on the outside. So, mga nasa terminal side lang sila. Okay? Yan yung tatandaan natin. Sige, i-illustrate na natin. So, ang central atom natin is si oxygen. Ilan ang kanyang valence electron? 6. So, 1, 2, 3, 4, 5, 6. Bakit ginanto ni sir? Hindi ko sinunod yung rule na pinigay ko when I teach you illustrating the LEDS of a given element for based on its valence electron. Kasi anak, we have to plan as well on how we can properly illustrate the structure, knowing that your hydrogen has only 1 atom. Okay, there are 2. Bakit dalawang hydrogen sinulat ni sir? 2 ang kanyang atom. Okay, so somewhat similar with how I discussed ionic bonding. Okay, be mindful about the number of atoms in the given compound. Now, this is sharing. There's no transferring of electron. So, alam naman natin exemption to the rule si hydrogen for your for octet rule. So, para maging ano siya, maging stable siya, you have to share this atom or rather electron to the oxygen. So, oxygen shares only 1 to your first hydrogen para maging stable. So, it acts like helium. Okay, kasi helium is stable. So, same with this one. Okay? So, check natin kung yung oxygen follows octet group. 1, 2, 3, 4, 5, 6. That's the valence electron. Dahil nag-share si hydrogen ng isa, 7. And another hydrogen here, 8 na siya. So, it follows octet rule. So, therefore, this is correct. Check natin dito how many electrons ang dapat makita natin sa structure based on the total amount of valence electron. 8. 1, 2, 3, 4, 5, 6, 7. So, we're good about the structure. Okay? So, nasusundan. Hopefully. Now, if we're going to identify the type of bond here, okay, number of bond, ang answer natin dito is single bond. Bakit? So, there is only one electron being shared to the elements here. Okay? For oxygen to this hydrogen, only one, as well as on this hydrogen. And hydrogen to the oxygen. Single bond. Now, polarity, for the polarity side, so you have to identify the electronegativity value of hydrogen and oxygen. This is just a sort of review. So, balikan natin itong electronegativity values. Hydrogen has 2.1 and oxygen has 3.9. Okay. So, 0.1, 3.5. Now, subtract lang natin this 3.5 to your 2.1. That gives you 1.4. Okay? So, 1.4 following the rule, polar covalent bond yan, if the value is less than 1.9 or equal yan sa 0.5. Non-polar covalent yan if the value is less than 0.5. Now, based on the answer, which one must be the right description here? It should be polar covalent bond. Okay? Sana nasusundan si sir. Therefore, for your hydrogen or your water, this is polar because of its value in terms of the type of bond, polarity, for polarity, polar covalent bond. Single bond siya based on the number of bond. Okay? So, hopefully, nasusundan si sir. So, another example para mas ma-intensify pa natin. We're using still this periodic table of elements for electronegativity values. So, we have CH4 or your carbon tetrahydrate. Okay? That's how you name it based on the rule. Pero as you move along with the other topics in chemistry, there's another method of naming this one. Okay? So, that's the beauty of chemistry. So, we have to identify still the total amount of valence electron. How? Identify the valence electron of each element. So, involving the formula, C and H, those are the elements. Okay? So, tingnan natin again ang position nila sa periodic table. Si carbon is found here. So, 1, 2, 3, 4. Okay? And your hydrogen is 1. So, that's their valence electron following the technique that I taught. So, carbon has 4, hydrogen is 1. So, these are the valence electrons. So, you have to transform this formula into an equation. So, there's no subscript you can observe here. Therefore, this is 1C plus 4H. So, 4 came from the subscript. So, substitute the value of the valence electron here for this equation. 1 times 4. Ito yung nanggaling. Plus 4 times 4. So, multiply 4 plus 4. Okay? Add this, you have 8 valence electron. Total amount of valence electron. Now, so, alamin natin who who among the elements here must be the central atom. From what I mentioned earlier, the central atom or the element that has the lowest number of atoms or subscript must be your central atom. So, yun. Hindi naman sila same. Kaya, we're no longer using here the second rule for determining the central atom. So, and then normally naman, ang hydrogen nyo, as well as halogens, they are found on the terminal side. So, nasa gilid sila. Central atom natin, C, carbon. And hydrogen, how many? Apat. Isa lang ang atom mo, kaya you have to write 1C here. So, 4. So, planuhin natin. So, I'll make it this way. Why? Para lang mas presentable rather ang ating LEDs. So, knowing for a fact that hydrogen has 51 valence electron, your carbon has 4. That's why I make it in this way. Okay? So, following octet rule, your hydrogen is one of the exemptions. So, this one. Your carbon must reach 8 valence electron to become stable. So, your hydrogen shares its electron to the carbon. So, bilangin natin. 1, 2, 3, 4, 5, 6, 7, 8. Check ang total amount of valence electron. Na-check din natin, or nasundan din natin si octet rule. Okay? Good tayo dyan. So, this is your LEDs for your CH sub 4. If we're going to identify the type of covalent compound based on the number of bonding, so this is single still. Single. Okay, because elements share only one electron to the other element. Yun naman yung rule. So for polarity, we have to get the electronegativity value of the elements involved. You again go by using this electronegativity value. So for hydrogen 2.1, for carbon 2.5, 2.1, 2.5, subtract lang natin, minus 2.1. So we have 0.4 using the rule. Okay, polar covalent bond less than 1.9 equal to 0.5. So lesser than 0.5 is non-polar covalent bond. So 0.4 to non-polar covalent bond. So again, this is the LEDs of your CH sub 4. Now, let's have the third example. We're going to still use this electronegativity values para mas madali ang ating pag-illustrate at pag-identify ng polarity. So we have your carbon dioxide or your CO sub 2. Okay? So same step, alamin natin ang kanyang total amount of valence electron. Yun pa rin naman yun, hindi magbabago. And then, gagamitin pa rin natin yung natutunan natin when it comes to your polarity. So, we have carbon and oxygen. So, PAVE. Your carbon has 4 valence electron. Okay, alam nyo na yan. Oxygen has 6. So, sana nasusundan because of its location sa inyong periodic table of elements. So, total amount of valence electron, transform it into an equation. So, subscript 1, 1C plus 2O. Substitute this, 1 times 4 plus 2 times 6. Okay? So, 4 plus 12, add them, you have 16. So, we have to make sure that there are 16 dots in the structure or electrons. So, identifying the central atom, so lowest subscript is your carbon. So oxygen must be on the terminal sites. Okay, this is how I present the structure. Okay, so you can put oxygen here if you want. Okay, as long as the bonding is correct. Yun naman yung importante. Now, we have to plan it. Alam naman natin na there are 6, so kulang ng isang oxygen tayo dalawa. Kaya I will put the dots on this side and the other side of carbon element symbol. Okay? So 1, 2, 3, 4, 5, 6. Same with this. Because your carbon shares 2 electrons to your oxygen to make it, or to, in order for it to follow octet. 1, 2, 3, 4, 5, 6, 7. Octet. So what about your carbon? Does it follow octet rule na? 1, 2, 3, 4, 5, 6. Not yet. So that's the reason why your oxygen here will share its electron to your carbon in order for both of them to become stable. So your carbon is stable. Bakit? 1, 2, 3, 4, 5, 6, 7, 8. Octet rule. Your oxygen here is still stable. Why? 1, 2, 3, 4, 5, 6, 7. Sharing of electron. How many dots na kailangan natin makita? 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is the structure. Now, what is the type of bond based on the number of bonds? So this is now double bond. Okay, hopefully you follow how you can identify if single, double, or triple. Because the element shares 2 electrons sa isa't isa. Becomes stable. So these electrons that you've seen here, the pairs of electrons here, are known to be lone pairs. Okay, pag tinanong, how many lone pairs do you have in your structure or in the given covalent compound? Ang sagot nito ay so pairing nga. So 1, 2. Ibig sabihin, lone pairs are those electrons. Okay? Electrons that do not participate in the bond. So here, this and this are not participating in the bonding. So again, these are lone pairs. Now for polarity, same procedure. Identify their electronegativity value. You have carbon and oxygen. These are the elements involved. Balikan natin itong table. Carbon 2.5, oxygen 3.5. 2.5, 3.5. Okay? So, hopefully you follow that. So, subtract lang natin. 3.5 minus 2.5. So, you have 1.0. So, following the rule, less than 1.9 or equal to 0.5 is polar covalent bond. Less than 0.5, non-polar covalent. So, therefore, this is polar covalent bond. Okay? So, carbon dioxide shows double bond in terms of the type of bonding based on number of bonds, double bond. It has 4 lone pairs, and this is a polar covalent bond. So, nasusundan. Now, for the last example, we're going to use still this electronegativity values of the elements. We have nitrogen gas, or N sub 2. So, these are one of the diatomic molecules. Examples of diatomic molecules. Same, kunin natin ng PABE, but we have to note the number of valence electron per your nitrogen. Balikan lang natin ito kung nasaan si nitrogen, what group. 1, 2, 13, 14, 15. So 5A yun. Yung 15, mayroon siyang 5 valence electron. Okay? So, hopefully nasusundan. So meron siyang 5 valence electron. Nitrogen has 5 valence electron. So we have to convert it or transform it into an equation, 2n. Yun lang yun. So saan galing si 2? From the subscript of your nitrogen here. So 2 times 5. Saan galing si 5? Substitute lang. Okay, that's the valence electron of your nitrogen. 2 times 5 is 10. So that is the total amount of valence electron for your nitrogen gas. Now, dati yung makita natin dots. So, no need for you to struggle in identifying which one is a central atom. Kasi you have nitrogen lang as an element, but there are 2 atoms. Kaya you have to draw 2 nitrogen here. Nitrogen element. How many? 5. So this is how I plan to illustrate it. Kasi nga, alam ko 5, tig-5 sila. So ilan ang kulang ni nitrogen to make it stable? 3. So 1, 2, 3, 4, 5. I make it this way. Okay, para mas straight ang ating na. 1, 2, 3, 4, 5. So, the nitrogen here will share 3 electrons to the other nitrogen. And the other nitrogen will also do the same para ma-reach ang stability following octet rule. So, 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen is now stable. Okay, octet rule. 1, 2, 3, 4, 5, 6, 7. This nitrogen as well is stable. Okay? Because of the octet rule, it follows octet. Okay? So, how many dots we have here? 1, 2, 3, 4, 5, 6, 7. So, check ang total amount of valence electron. So, for the type of covalent bond based on the number of bonds, alam naman natin there are 3 electrons being shared to one another. So, this is triple bond. Shows triple bond. It has triple bonds. Lone pairs, yung electrons that do not participate in the bonding. So, pair nga, 1, 2. There are 2 lone pairs. So, polarity. Namin natin ang polarity by getting the electronegativity value of your nitrogen alone. Pero dalawa yan, kaya you have to subtract it sa same electronegativity. Balikan lang natin itong table. So, may 3 for your nitrogen. So, 3.0. So, 3.0 dahil dalawa minus 3.0. You know what the reason behind it? No? Hindi naman porket dalawa yung atom ng hydrogen sa water or H2O mo. Dalawang beses mo isusubtract. Okay? Yung value ng electronegativity. No. Okay? Basta there are 2 elements involved. That's the thing that we have to subtract. Pero for this case, this is diatomic, kaya you subtract it on itself. Okay? So this is 0. So 0 less than 0.5 is your non-polar covalent. Okay. So therefore, your nitrogen gas shows triple bonds. It has 10 total amount of valence electron, and the polarity is non-polar covalent. And that ends my discussion. Hopefully, you learn about how to properly illustrate the covalent bonding of a given compound for your covalent compounds. And hopefully, you observe as well that you reach or attain all the learning goals that I mentioned earlier, which are your nomenclature, how to name and write chemical formula for covalent compounds, and how we illustrate the LEDS of covalent